most of the board examinations under matrices, the long answer type questions may appear from the solving of simultaneous equations in 3 variables, that is x, y, z. But we have 3 different methods. The one of the methods is Cramer's rule, and second method is matrix inversion method. Third one is Gauss-Jordan's method. The first, let us have a discussion on solving the simultaneous equations in 3 variables, that is x, y, z, using Cramer's rule. So, first let us have a strategy in Cramer's rule. Basically, so in general we have to remember the steps that are to be actually applied while solving the problem using Cramer's rule. In Cramer's rule, first step 1, first we have to find out delta. So, that is the determinant of the coefficient matrix, and delta 1. So, that is also determinant, delta 2 and delta 3. Now, x is equal to delta 1 by delta, y is equal to delta 2 by delta, z is equal to delta 3 by delta. So, first let us solve it, how to solve this problem. But moreover, before going to solve using by adopting any one of the methods, first we have to write the simultaneous equations in terms of matrix equation. So, first let us write matrix equations. So, now solution follows. So, this can be written like this: 2 minus 1 3 1 1 1 1 minus 1 1, this is 3 by 3 matrix, multiplied by x y z equals to 9 6 2. This form is called matrix equation. So, that means it will be in the form of Ax is equal to D form. This is called matrix equation. Matrix equation. Here A is called coefficient matrix, X is called variable matrix, D is called constant matrix. So, that means here A equals to 2 minus 1 3 1 1 1 1 minus 1 and 1. Okay. Let us find out the determinant of this A. Let us say that is delta. So, delta is equal to delta of 2 minus 1 3 1 1 1 1 minus 1 1. So, let us find out the determinant of 3 by 3 matrix. So, that can be done taking any row or any column by expanding. Here 2 multiplied by delta of its cofactor. Its cofactor means deleting this row, this column. 1 1 minus 1 1 1 1 minus 1 1. So, here minus, actually minus of minus 1 delta of deleting this row and this column 1 1 1 1. So, 1 1 1. Next plus 3 its cofactor. What is its cofactor? Deleting this row, this column, we have 1 1 1 minus 1. This is 2 by 2 matrix. The determinant of 2 by 2 matrix is, for example, A, B, C, D, AD minus BC. So, this we can write 2 times 1 minus 1 into plus 1 here, and plus 1 1 minus 1 plus 3 minus 1 and minus 1. Here 2 into 2 plus 1 into 0 plus 3 into minus 2. Am I correct? 4 plus 0 minus 6. So, this equals to minus 2. It does not equal to 0. So, that means it has the solution, otherwise it does not possess solution. Now, delta 1 let us find out. So, delta 1 means very simple. Here I will tell you the logic here. Now, the first column of the here delta is replaced by the constant matrix in order to get delta 1. So, that means here this is replaced by this 962. So, write down 962 instead of 211. You keep C2 and C3 constant, you need not change. Minus 1, 1, minus 1, 3, 1, 1. Let it be expanded using row 1 to get delta 1 here. Now, I will write directly 9 multiplied by determinant of this one 1 plus 1, correct. Here minus of minus 1. So, deleting this row and this column, 6 into 1 6 minus 2, 6 minus 2 and plus 3 multiplied by, so minus 6 and minus 2. So, this equals to 9 times 2 plus 1 times 4, correct, plus 3 times minus 8. So, now 18 plus 4 minus 24. So, 18 minus 20, that is minus 2. This is delta 1. Let us find out delta 2 now first. Delta 2. Okay. Now, delta 2. Have you expected what will be the delta 2? Yes. So, now in delta replace second column by the 962. So, now delta 2 equals to that of keeping C1 C3 constant 211, this is 962. C2 is being replaced by the constant matrix, that is 962, 311. So, let it be expanded by the same R1. What do we get it now? 2 multiplied by, deleting this row, this column, determinant of this matrix, 6 1 ja 6 minus 2 and minus 9. See, deleting this row and this column, 1 1 1 means 1 minus 1. It may be 0, do not worry that part, plus 3 times, deleting this row and this column, 1 6 1 2, 2 minus 6. So, 2 times 4 and minus 9 multiplied 0, 3 times minus 4. So, 8 minus 0 minus 12, this is minus 4, delta 2. So, now it is the time to find out delta 3 so as to get the Z value. So, here delta 3 means you might have expected keeping C1 C2 as it is constant, change third column, 311 is being replaced by 962, that is all. So, now here 2 1 1 it is kept constant, minus 1 1 and minus 1. Next, here this is replaced by 962, which is the constant matrix 962. Let us expand it. 2 multiplied by, delete this row, okay, this column, this row, this column, 1 6 minus 1 2 determinant, 2 plus 6. This is minus of minus 1 and here see this row, this column, 1 6 1 2, 2 minus 6. and plus 9 multiplied by, relating this column, determinant of this matrix, minus 1 minus 1. Now 2 times 2 plus 6 8 plus 1 into minus 4 plus 9 into minus 2. Check the calculations carefully. 16 minus 4 minus 18. This is 12 and minus 18. This minus 6. Now we need to find out x value and y value, z value. Here x is equal to delta 1 by delta. Delta 1 is minus 2, delta is minus 2. By minus 2 by minus 2 cancel, we have 1. Now what is y? Delta 2 by delta, that is delta 2 is minus 4 divided by minus 2. 2. Now delta z value, delta 3 by delta. So delta 3 is minus 6 divided by minus 2. Minus minus cancel, 3. So therefore x is equal to 1, y is equal to 2, z is equal to 3. Hence it has been solved using Cramer's rule. So this is called Cramer's rule. In the next episode we will discuss some other examples on Cramer's rule.